Vectors have magnitude and direction both. So when we multiply vectors, we have to see whether the product is having only direction, only magnitude, or both. Depending on this, we classify vectors product in two parts. One is known as scalar product. Sometimes it's referred to as dot product, and very rarely it's also known as inner product. When you multiply two vectors A and B by this method, simply you'll have to put dot between them, and the product is going to be AB cos theta. Right side you are not having any symbol of vector, that means right side has got no direction. So this is the method in which we multiply two vectors and get a scalar. The product is not having any direction. For this, you see, here theta is the angle between both the vectors, that is A and B. This angle is theta. Angle theta is variable. It can have any value from 0 to 180 degree. Depending on the value, obviously, since cos theta appears in the equation and that's variable, it will be positive if theta is less than 90 degree, and it's going to be negative when theta is greater than 90 degrees. This is obtuse and this one is acute. Now, you have many properties for this dot product. Prior to that, we must be knowing some examples like work. Work itself is a scalar, but this is the dot product of force and displacement. You can amplify it, you'll get FB cos theta. Likewise, when you get electropotential energy, this is the dot product of dipole moment and electric field. There are many other quantities which you get by multiplying two vectors in this method. Now we'll refer to characteristic of this product. Above all, this is commutative. What does it mean? Means no effect of changing the serial or the sequence. You multiply A by B, or better to say B by A, in both the cases, it's going to be same. Second, it is distributive. Distributive means simply you need to multiply by dot method vector A with B plus C together. Then this will be split. It could be A dot B plus A dot C. This property shall be known as distributive. Then third property is, if theta is 0, cos theta has the maximum value here. And that way, the dot product is going to be maximum. What shall be the maximum value? It will be A, B only. Maximum. Similarly, if you take theta 190 degree, it's going to be, cos theta is going to be -1, and there you get the minimum value, minus A, B. If theta is 90 degree, cos theta becomes 0. And in that case, obviously, A dot B equal to 0. This is very important property. Means whenever you want to prove that two vectors are perpendicular, you have to check whether their dot product is 0 or not. This is the acid test for the perpendicular nature of two vectors. You want to check two vectors to be perpendicular, simply check the dot product. Now these two examples can be applied. See, here it was theta 0. You could write I dot I. Both are 1. The value will be A dot B. A is 1. Unit vectors have one value. A dot B, this will be I dot I. That means 1 into 1, that is 1. Similarly, J dot J will be 1, K dot K will be 1. Here, I, that's along x-axis, j, that's along y-axis, their dot product, since they are perpendicular, one is along x-axis, other is along y-axis, it's going to be 0. Then j dot k, k dot I, this 2 will be 0. Let's apply this property again. There is a vector A. We want its dot product with itself. Like you say 2 into 2, this is 2 square, this is 2 power 2 or 4. When you square something, it means you multiply by the same. If you want vector A square, what will you do? Vector A square means A dot A. This is A, its value, and cos angle between them. Since both the vectors are same, angle between them will be 0. So here you will write cos 0, that becomes 1. Cos 0 is 1. So it's going to be A square. It's very important here to remember that square of any vector, if it is considered A square, it simply means dot product has been followed.